All right, welcome back to Corona Geek. This is number 188. It's hard to imagine 188 shows, but they're all there. You can find them at youtube.com/Corona Geek, along with all the show links. Most of the videos have links to the blog post on coronalabs.com, which has all the show notes. So if you are confused by that, just click on the link in the description, and it will take you to all the goodies. Usually we have files that you can download. And all the references to panelists and everything else that's there. So go check that out. Today joining us, we've got Stephen Johnson from the Bubble Studios. We've got Mike from Crave Creative, and myself. So I think Renee is supposed to join us at some point. There's Jason. Hey, Jason. So people are going to drop in as we go along, which is totally cool. We've always wanted this to be sort of an informal, sort of casual sort of a setting. So if you ever want to join us, just let us know. You can always email me, charles@coronalabs.com, and I'll add you to the mailing list. We'll send you an invite. Well, I tell you what, guys, we've been doing a lot of things in the community. We've been doing a lot of things on the Corona Labs side of things. One of the things that we've done here recently is we implemented an auto message system when developers sign up for Corona. So, previously, I don't know if you've been in the community a long time, you may have received a welcome message back in the day, sort of thing, and it was all kind of, like, hey, just thanks for registering, and here is your welcome package, and that kind of thing, and that's still true today. But what we did was we actually went ahead and put in a few auto messages to kind of say, hey. Here, you've registered. Here's your materials for getting started. Then a few days later, it sends a message from me, which is a message that I would have sent anyway to them personally. But there's so many people who register per day for Corona. There's no way I could humanly do that. But it sends them a message from me and says, "Hey, if you have any problems, let me know. We can jump on a call. I can walk you through." And that sort of thing. And then I think then after that, they get, some subsequent messages just to sort of follow up and keep the relationship going. So I've been getting about 5 or 10 emails a day from people who are like, hey, this is great. I like Corona. I found the docs. There's lots of great material. What else you have? And they want to know if we have getting started materials, if we have tutorials, if we have like a step-by-step guide and that sort of thing, which are all things that we have and things that we're working on. So, I just basically point them to those resources. So we're going to refine a little bit of the process there and make sure that everybody can kind of get the information they need. But it got me to thinking about tools. It got me thinking about what is it that people use. What kind of tips do you have for somebody who's just getting started? So I think today I can see we've got Renee with us. Renee's going to talk about Quadtrees. Stephen can talk a little bit about message. I can't even say the word meshes. And if we have some time at the end, I think we should all just kind of throw in what we think our tip is for somebody who's new. Where can they go? What's the best learning resources that you've experienced? And as I think Jason and or Sergey probably jumped in here on the chat says, what is a good primer for people who are new to Corona? So we've got a couple extra faces here. We've got Rob Miracles joining us, Lurk's joining us, and then Renee I is joining us from Germany. It's nice and bright and sunny. You're on mute, by the way, Ray.
Yeah, no, don't. Can you hear me?
Yeah, I can hear you now, Renee.
Okay, anyway. Yeah, thanks for having me.
Yeah. So let's get into which comes first, a conversation about meshes or a conversation about Quadtrees? You're both on mute. Renee, you're on mute again.
I'd say to do the Quadtree first.
Do the Quadtrees first?
Yeah.
Okay.
The Quadtrees, okay.
Do they do Quadtrees tie into meshes? It seemed like there was some connection there.
Between Quadtrees and meshes?
Yeah.
Not exactly, I think.
Okay, good. Well, then, for those who don't know, then let's talk about Quadtrees. Renee, tell us what Quadtrees are, and your experience with them, and how we might use them.
Yeah, Quadtrees is a technique to create better performance with collision detection, especially when you have many objects in the scene. And that's it. And
does it make things faster, or is it more efficient, or is it just a way of kind of breaking things up?
Yeah, it's special sorting of objects by distance, and so performance of collision checks. The number of collision checks get reduced by this technique. And I have prepared. Yes, I have prepared a screen. I can show you this technique.
Yeah, absolutely.
What Quadtrees is doing. Let me share my screen. It's there. Okay. This window. Share the screen. Okay. Do you see this now?
Yes.
Okay. Okay. Let's say this is our scene, and we have a bunch of objects here. These are 20 squids in the scene, and a non-optimized collision check system would be you take the first squid in your list of objects, or your table of objects, table of squids, and do a collision check with the next one, and then with the next one, and all the squids. You iterate all the squids through the list. And that was the checks for the first squid. And then you go to the second squid and do the checks with all the other squids. You can optimize this. You could check if two squids have already did a check, so that you not double check them, to avoid this double checking. But let's assume this simple example. So if you have 20 squids, you take the first one and you do collision checks with all other 19 squids. And then you do the same steps with the second squid until you have checked all 20 squids. In the end, you have 20 by 19 collision checks in this case. This is 380 collision checks in sum. So what Quadtrees does now is, take a brush here. Yeah. Quadtrees optimizes the collision checks. It creates branches. The first branch is our whole screen. This is the first branch of the Quadtrees system. And when you initialize the Quadtrees system, you have to say how many objects are allowed to be in one branch before Quadtrees subdivides this whole branch into 4 smaller branches. That's why it's called Quadtrees, because of the subdividing into 4 branches. So in this case, I take the number of 5 maximum objects in one branch. So a quick check, you can see here are more than 5 squids in one branch. So Quadtrees divides this into 4 sub-branches. And then again, Quadtrees checks each single branch if there are more than 5 objects. So in this case, we have 6. So Quadtrees divides this again. And then this branch is okay, only 4 objects. Here are 4, and here are again 6. So this would be divided again. So Now everything is fine, and no branch has more than 5 objects. So now we can do the collision checks itself. And the cool thing is you only need to check squids that are on the same branch. So in this case, this little branch does only have one squid. There's no collision check. This one have 2 collision checks. Again, you can optimize further by avoiding double collision checks, but in this simple example, these are 2 collision checks. Here again, 2 collision checks. Here 4 by 3 collision checks. This is 12. 2 and 2, 0, 0, and again 12. If you sum these numbers for collision checks, this is way less collision checks than 380.
Makes a lot of sense.
And yeah, that's the idea of Quadtrees.
And you say you define how many objects can be in a branch. So I guess that's, you're just sort of guesstimating that, or guessing at.
That's the playing around with what values are best. If you have many objects, maybe higher values does make more sense. You also have to choose a value for the smallest branch size. So this is the first branch. This is the second depth of branch, third and fourth, and you have to give a maximum number what Quadtree subdivides the whole scene into smaller branches, and you have to play around with the values for that.
Okay. So what's the code look like for this then? Because I'm curious as to how. I mean, this is all happening sort of frame by frame, right?
This is indeed frame by frame. Yes, I have some example code. Let me load it. 1 second. Okay.
Sorry, I'm late.
No worries. Glad you're here.
I suppose I should put my whole head in the frame instead of doing that. I know somebody else who does that, Stephen.
It's part of his charm.
I'm almost expecting it that all the time, though. It's just the way he is.
I love it. I'm glad you could join us, Ed.
Thank you.
I'm worried about you. I thought maybe,
No, I just, it's just so busy this morning, I totally forgot what time it was.
That's cool. Well, Renee is teaching us about Quadtrees.
Yes, indeed. And I can you see this example here?
We did, but now
we had it for just 1 second there.
Now.
Yes.
Yes? Okay, I reloaded.
Oh, and it went away.
Okay, when I
Yeah,
reload
you can't focus a specific window and reload it. It gets a new ID every time. You got to share your whole screen or not relaunch.
Okay. So, desktop, yes, okay. So, now you see this.
Yes.
Okay, so this is an example without Quadtrees optimization. We have 98 objects, and without further optimizations, we have 9,506 collision checks per loop. That is very much, and you can see the frame rate. The frame rate drops to 7.
Can you command plus on that? Can I make it, zoom in?
Sorry?
Can you zoom in on the simulator? Zoom the simulator, like window.
Bigger one?
Yeah. Zoom in.
You may need to choose a different device. What's your screen resolution?
Okay.
Oh, there you go. He's got a huge monitor.
Yeah, you're right.
This better?
Yeah,
It's
it's
better.
good.
Okay, fine. So, too many collision checks, 9,106, 7 FPS. This is slow, and this is without Quadtrees. And if I
So in that example, just for those who may be listening to this and not necessarily watching it, you are bringing up a grid of green squares that are all columns and rows, and then they're just doing their individual collision detection as they would normally.
Yes, just some objects and simple overlapping rectangle tests for collision checks.
Okay, and then as the green dots, green squares interact with each other, then they turn red because they register a collision, but they're all sort of moving around
randomly.
Yes. So they don't stay in a grid pattern. They sort of move around. So okay.
Yes, exactly. And now the same with Quadtree should give.
Yeah, and when we read the code there, when we start reading the code, we'll ask you to bump up the font size on the code as well, please.
Yes.
Yeah.
Okay. Okay. Here, in this case, the debug mode is on, and you can already see the branches that are created and released again. As you can see, 98 objects still, and the collision checks, number of collision checks is reduced around 1,000. And 27 FPS. It's better, but it's not super cool.
Well, it is good. It is though, because we went from 7 frames per second up to almost 27, almost 30 frames per second, and we dropped the number of collision checks from, what was it, 9,000 before to just under 1,000. It's great, and it looks like it varies, of course, depending on where the objects are in relation to the rest of the screen, right? So if they're all kind of clumped together or spread out, it makes a difference.
Yes, exactly. In every game loop, the Quadtree checks again how many objects are in one branch, and then if they are clumped together, then it creates more branches.
Yeah, it seems like that would be a significant performance saving, especially if you are not. I mean, you obviously have a bunch of objects on the screen, but maybe you don't have that many objects, and you still want to maximize the performance.
Yeah. Might be for a scenario where you have many bullets flying around, maybe. But you must have in mind the Quadtree technique does have a lot of overhead, because all the time you have to check how many objects are in one branch and create new branches and move them to other nodes, etc. And you have just to test out if this is really better for your system, if it suits your system.
Okay, that's kind of fun to watch. So how does the code work?
Yeah, I have.
And can you bump up the font just a little bit more, please?
Even more. Can you see now? Yes. Okay.
Much better.
Okay. I hope I can tell you something. It's some weeks ago since I wrote this.
Well, let's start off by let me ask you this: is this code available someplace?
Yes, I can. I will give you a download link for this whole example project, and then you can test for yourself. Okay. Well, you don't have to go through it line by line. Just sort of give us the overview of the concept, and then people can download the code for themselves. Yeah. Maybe how to create the Quadtree itself. Here's the setup of the Quadtree. Sorry. And here you have to give the screen size, the size pixel size the Quadtree has to check for. This is the debug mode. You can set this to false, and then the red lines are gone. And this is what I said. The values you have to play around with. This is the maximum numbers of objects per branch before Quadtree subdivides into smaller branches, and the maximum depth of branches that are created. And are these two values.
So, what's the beginning one there at the beginning?
Yes, I asked myself, what is the one? What is P level? Must be one. Sorry, I don't know why this must be.
There can only be one.
It can only be one, yeah.
Okay, and that makes sense because, again, you said that in this case we were making it the entire size of the screen, so that first P level is basically your screen.
Yeah. Yes, I think it's the start branch number, and I think it doesn't make sense if the branch number is not one. The starting branch number. Some kind of this maybe. Okay, and in the Quadtree itself, we have it's a recursion system. You create branches. I said branches. In the source code, it's called nodes, and the big nodes create smaller nodes, and the collision checks is done by recursion from the smaller nodes to the biggest nodes in the end.
Yeah, I don't think there's really, I mean, conceptually, it doesn't seem like there's a lot to explain, right? I mean, you explained at the beginning, you said you have all these objects within a branch, which in our case is that very first branch is the screen. So then I assume it goes through and figures out how many objects it has on the screen and says, that's more than the allowed amount. And then it just goes in and starts subdividing the screen until it gets to the point where the conditions are met, that it's a valid condition.
Mm-hmm. It's a lot of pushing objects through tables, getting them in tables and out of tables.
Hey, does your implementation allow an object to be in more than one branch at a time?
And there's a special case where one object is not exactly in one branch or the other because it's exactly at the border of two branches. And in this case, this object is in the bigger parent branch.
Okay, that makes sense. Okay. Otherwise, you'd end up having the worst case be up to 4 branches containing the same object. So, right.
Yes, that is. I have to test.
Yeah, I noticed that it only seems the quads only seem to get so small, right? There's the big screen, then there's the first subdivide, right? So you have 4 blocks, and then after that you have a certain number of grid blocks, right? That appeared on the screen, and then after that there was blocks inside of a block, I guess you could say, and then it just seemed like it never got teeny tiny, right? It never got really super small. Have you ever seen a condition where it gets like the quads get like really super small?
You mean with the quads, the branches, the size of the branches?
Yeah, because the branches seemed like they were visible, right? They were still visible, even though it was a quad inside of a quad inside of a quad or something. But have you ever seen it where it's like it gets like teeny tiny, like you're like super super small?
In this case, this relates to the number of maximum nodes, subnodes you enter. At a certain level, it doesn't make sense to make so many subnodes because there are too few objects to check collisions for. It would be possible, but I don't think it's will kill the performance in the end.
Right, it's counterproductive, right? And that makes sense because as you're talking about it being recursive and at some point you have to hit a stopping point where you don't want to subdivide anymore. So that makes sense. For some reason, I was just surprised when I was like, oh, look, they don't get any smaller.
How frequently do you update your branches?
Sorry?
How frequently do you update your branches? Every frame?
This is every frame in this case, yeah.
Okay. My brain is just iterating over the ways that you can optimize individual elements of this algorithm.
Ed, are you thinking like every other frame? What do you?
There's a number of things you could do. You could do every other frame. That's not necessarily the best approach. You could also pay attention to the velocity of objects and let that decide when one branch is more active than another. I mean, it depends on how many objects you're dealing with, the cost of what you have to analyze every part. How much does it cost me to analyze the branches every time versus how long so you measure the different algorithms and come up with something that's like ideal for your situation. I love Quadtrees and Octrees because everybody like looks at them and goes, oh, that is so complicated. But really, it's just an iterative set of steps that you have to understand each part, and then you can break it down into something very easy to understand and like tune. So this is cool.
It's quite, it has an elegance.
Very, very elegant. That's the other part I like about it, because it's one of those things where once you get past how it's sort of a little scary mathematically or algorithmically, then you're like, oh yeah, this totally just makes sense.
And if you're only changing certain things, you only need to change part of the quad tree, right? If you only change a few things, you don't need to tear down the whole quad tree and update the whole thing. You can just replace the changed parts.
This would be you could do this is an optimization step, I think.
So what you're saying, Stephen, instead of rebuilding the tree every time, evaluate a branch to see if it needs to be updated.
In this example, the whole quad tree is updated all the time, but there is room for
makes sense for your
optimization.
See, you don't want to have Steve or I over here on this, because we're just going to give you all these ideas how to change your algorithm. You're like, I just want to show the base algorithm. Just leave me alone.
Well, is this Renee? Is this on GitHub?
What I can have?
Yeah, if it's on GitHub, I think that Ed and Steven should submit some.
Yeah, that's your answer. You should do that. Money where your mouth is. Whatever you want to do, I'll send you. I think I do that occasionally with. He's not online right now, but Sergey, I'm like, that's a good idea, dude. I'm gonna give you a copy. You make that change. Sergey calls me on things sometimes. He's like, Ed, I think there's a better way.
Yeah, I'm a big fan though. I'm kind of being funny, but I'm also serious. I'm a big fan of GitHub and code sharing. So and I know that it seems like in the Corona community, people kind of put it as a repo for sharing with the community, but I don't know how many people actually go through and push or submit pull requests. And I think we should probably do more of that, because then we could create these really tight examples of things and help each other with optimized pieces of code.
I'm a little late to the GitHub party in that sense that I used to self-host my modules on my site. I'd occasionally have people do the old-fashioned equivalent of a pull request. And I'm moving towards GitHub for just that reason, because I just want to simplify. It also makes it, a better way for people to get credit for when they're working on it. We see who's contributed to something, and so yeah, I'm totally on board with you there, Charles.
Yeah, and free labor never hurts. Getting someone else's brain power on something, that's cool. All right, Renee, thank you for that. Send me the link. Yeah, definitely share the link, put it in the chat or whatever, and then we'll share it with everyone, and they can go check it out. And then Stephen and Ed will, contribute to this to the repo.
That's great.
Cool. Well, let's talk about meshes. I know Stephen wanted to talk about meshes, and I just saw that Vlad jumped on, even though he's hiding back there behind his camera someplace. And I know he is the mesh master. I just I just gave him that name, Meshmaster.
Meshmaster. I like
Meshmaster.
I like Meshmaster.
I'm gonna get you a T-shirt.
He's not also Meshmaster. He is like graphics master in general.
Or Mesh Monster, one of the two. I don't know. We'll work with it. Anyways,
one of his Pokemons.
So Stephen, what did you have that you wanted to share? What did you want to talk about? What gets you up in the morning when it comes to meshes? You're muted.
Okay, well, when the canvas feature came out a while ago, I started playing with this. That we had shader, or we had textures we could edit. I could cram in geometry information, and I did some tests with Spine, which was lacking that feature until then, right?
Okay.
And so if anyone has seen the Spine runtime, or there's a thread, something about Spine is the only runtime, or Corona is the only runtime without Spine meshes, something like that. It's that sort of feature. And let me see if I can.
Well, Vlad may have something to say about this, because Vlad, I know you've been working on meshes and you've been working on some spine support stuff too. So, throw in here if you need to. Yeah, I see that.
Okay. So if you look at the tail of this dragon here, or the rope,
yeah,
that it's not only the corner part of the object that's changing. It's actually, there are vertices in the interior that are also changing, both in texture coordinates. So that would be, say, in an image sheets, the positions of the corners of the frame. Basically, that same thing.
Okay.
Those are all changing, and they're deforming. They're not. The points aren't just moving. They're all moving together, and they're shared between each other because there's points that meet at a common position. And I'll see if I can.
Yeah, I see that the outline of the object is moving, right? So that the individual points along the object are moving, but also that the texture within the outline is moving as well. So it seems like it's all a mesh. It's moving all at the same time.
Try to click on this demo you're showing.
And what?
Just click on the demo you're showing.
Oh, you had that already. Okay. I was about to do that in code. Right. So you can see the points moving around where the point is shared among several polygons rather than simply the corners, as you would see in a quad, for example. Mm-hmm. So when you move one of these points, it'll move all three triangles that are connected to it.
Okay, so for those who are listening and not necessarily watching this, you've clicked the demo, you've tapped the screen, and basically it's turned into what looks like a wireframe representation of everything moving around.
Yeah, this is what the geometry looks like under the hood.
It's pretty cool looking.
So you can get pretty smooth because you're able to manipulate all of this at the same time. And say again.
Oh, can I make another demo? I just have something. Yeah, after you're done.
Vlad, you have a demo you want to show off too?
Yeah.
Okay. All right. I'll cede the floor.
He's yielding his time to the good gentleman from California, or Canada, actually. You're in Canada, right?
Yeah, I'm in Canada.
Yeah.
Okay, let me show what I got. Where is it?
Yeah, you'll have to share screen.
Yeah, I understand. I have to open a project.
Okay.
Okay, so here's a project. It's a actual latest example Spine has.
Okay, so just so you know, we don't see your screen yet. Okay, there it is.
So it's like a T-Rex, and it's a boy riding T-Rex. I'm not sure if you can see it.
Yes.
So I did the same thing as you just saw. So we can click and see, like, if you look at this leg, it's not just like switching. It's actually like deforming while it's moving. So what's going on? Like, what's the like cool like benefits of such animation techniques that you can like, you know, do some slow motion and stuff, which you can do just with sprites. Also, you can do stuff like bend a little, and you know, it would be really hard to achieve. Like you see, like muscle of the leg, like it kind of like expands when the raptor steps. So you can, it's like you would have to change sprites to do it in a classic like thing. So also how this demo works, like if you go and look in the code, or better just in the sources. Let me.
Yeah, so you would be able to do with sprites. You could do a walking animation, but that would have sort of each body part would have sort of a rigid, repetitive motion. And what you were saying in that example there was we could see sort of a flexing almost of the individual body parts. So it looks more like a muscle flex than just a left right leg walking.
Yeah, I mean, this stuff is like obviously computationally expensive. Like it's not something you want to do for like every tree everywhere. But like, yeah, I mean, there are some parts which already been there. Like, you know, like Spine allowed you to move like smoothly. Like these are debug bones you can see. Spine already had it before meshes. So basically you could like move your sprites around, but you couldn't like see bend the tail. Like look at the tail wag, it has like a tail wag. Like how would you even do that without like ugly stitches or something like that?
Yeah, this is cool. This is awesome. So okay, so where are we now, Stephen?
Okay, I have a few other examples that I'll show now.
Okay.
Stephen, while you bring that up, can I ask a question?
Sure.
What kind of performance are we looking at right now on device? I mean, I know that's a nebulous question. Specifically, like the example there from Spine, the modified Spine example with the dinosaur and the boy riding. I mean, what kind of frame rate are we looking at on that?
Well, the previous version, which is pretty much emulated the stuff I did before, that ran fine, and I didn't get any complaints from Tom Surmania, who was using it. He's been using it, and he hasn't whined to me about, hey, this is slow. So that wasn't even the dedicated Corona version.
Vlad's slinging us a screencast of a
yeah, it's running at like 60 FPS. I have like 3 Spine Boys and the Raptor. They like doing fine 60 FPS on, well, it's iPhone 6. It's not 6S, but still it's a pretty beefy device.
I mean, this is using OpenGL features that are pretty much tailor-made for this. So
I was kind of assuming that because we're using the OpenGL pipeline here that we'd be getting that benefit instead of just like.
Yeah, I mean, it's not that like. Also, what I did for this demos to work, I implemented the like Atlas loading, which Spine provides, so we don't have to. Like before, you had to have like individual image for every piece of skeleton. I implemented the Atlas loading, so it becomes like way faster. I did a little bit profiling on what was taking most of the time, like with some animations. And for me, it was that it's like loading and opening files because Spine runtime didn't really, handle resources properly. So it was unloading and loading images.
Yeah, you ended up loading and reloading the same files.
Yeah, so, and like if you're using Atlas, it's not an issue. So it like I got like instant performance boost even on the same animation with that. I mean, you could have done it manually without a problem. Yeah, so
well, this is good. I'm glad. I mean, long story short, I tried the Spine out a long time ago, but I wasn't happy for a number of reasons with performance, so that I haven't really used it much since then. So this is good.
I mean, performance is still, it's not super amazing, honestly. It's good.
It's like a dozen times more complicated than using two pictures, right? And just changing their position.
Well, but if you want to have your like main character really like looking looking nice, you can totally do it. You don't want like make mesh out of every grass on your screen, which you can totally do in like PC video game, which it is, but not in a mobile or not in Corona, because Lua runtime we're still using Lua runtime, and it's in Lua, and it's not like the best way to crunch numbers, honestly. It's good enough. I think it's pretty good description.
So Stephen, you're showing us there what, a piece of cloth?
Yep. This is it's meant to emulate cloth. It's using physics to tie all the points together, and they're just bouncing around under distance constraints. And so what I do is I divide the geometry all across every little X cell and every little Y cell, and then let it go. And basically update the positions, leave the texture coordinates alone. And it behaves like a cloth. It's a little jittery in some ways, but it's demonstrating the principle.
Nice. It's jittery just because the wind blows. That's what it is.
Yeah, with certain parameters, it gets really jittery, and then it starts curling up on itself. But that's just tuning.
So Vlad, what happens next? What's the so now we've got this. What's the next step?
Well, we like in Corona, we have like weird policy where we don't like promise anything, because if you promise some things, then you usually just can't deliver on it just because Murphy laws or something.
Sure.
So, but like what we're doing in the immediate future is basically getting it like fixed, because stuff I'm working with, it's like I think it would work only in the like very latest build, which is like 82 or something. So it's obviously got some like last minute fixes, and I added some stuff. Like that's part one. About Spine, there are some mistakes, and like, okay, so honestly, it was a lie that like Corona is the only runtime which doesn't support meshes, because non-Lua runtime supported meshes. So Corona is actually first Lua runtime user which supports meshes. Like Love doesn't support meshes with Spine. So those people are liars, because I was like not me, like Steven Johnson was the first person who got like meshes working. Great job. It's like really amazing stuff. And after I tried some more, it's like their runtime, like Spine runtime for Lua, which is generic. It had some bugs and didn't work, and you had to like go and fix some code you don't expect to fix, like you expect it to work and stuff. So for now, there are like open bugs that like Lua runtime, like generic Lua runtime, has like multiple problems, and but I believe the Spine like guy Nate, he promised that it would be taken looked upon, and I will contribute if I would be able to fix something. Okay, I'll just give it back to Steven Johnson to show off his amazing business.
Yeah, what are you doing here, Stephen? You're like you're altering the points of a picture and kind of squishing it around, moving it around. Right.
This is a plugin I'm trying to make for morphing, essentially. And there's a research paper that I have long had my eyes on, but I had no real sane way to implement it until now, where it's called Poisson coordinates, which are basically a way, given some properties of the boundary of an object, to smoothly interpolate into the interior. so that if you change something on the boundary, it'll affect everything inside as a combination of the interior. And I didn't get anything ready, an example demonstrating this, but what I have save and load of this boundary. And what I want to do is, you can save a configuration like this, and oh, that's not good. So it's broken in the meantime. But you could save one configuration and then save another and blend between them so that you could have an object that was morphing from one shape to another.
So give me an example in sort of practical real world terms, right? I mean, I can kind of wrap my head around the potential for this, but just to make it easy for someone to understand, what would be a good example of this?
Like the T-1000 in Terminator 2.
Okay.
That kind of thing. So you'd have an original shape and a target shape, and you would blend from one to the other. Basically, probably make a wrapper around it so you can use transitions on it. And you could have the alpha fade from opaque to semi-transparent, and then do the same thing with another image and fade them together. That's one of the things I have in mind.
And so would these objects be just sort of programmatically created objects, or objects that you could manipulate programmatically?
Well, like this. I mean, this is sorry about that. This is my editor, I guess. So something like this. I have these saving to just JSON files, and then you kind of give it a.
Okay, so I could interact as a user. I could interact with objects on the screen, maybe change them in some way, and then morph from A to B. So it wouldn't be necessarily be two objects that are in that the programmer put into the app, and then they wanted to transition from A to B. It's more like whoa. It's more like the user's created something, and then you want to be able to allow them to morph from A to B.
You would probably do this in a step offline, pre-processing step, and then use it in the game.
Okay.
I just want that right there
Uh-huh.
to be a snippet from the show. Just like in the right timing there. I don't know what that was. Either a motorcycle or a very unhappy cow.
Just a motorcycle.
Okay. So I just want to clarify something here, Stephen. I think you undersold this. So what you're saying, this is a mesh morph.
Right.
One mesh to another morph. Okay, one mesh to another mesh. So whether or not you can control the lineal, per time transition of individual elements of your mesh, or if it's just everything transitions at the same rate, is a question. But you went on to sort of undersell it as just morphing between two images, which is totally different. When you gave us a T-1000 example.
Yeah.
So what should he have sold it as, Ed?
No.
I'm serious. I'm being serious. I understand that we tend to undersell our things that we create and stuff like that. So give us another example to help us.
Okay, so what I heard here is that you've got two meshes, perhaps more if you wish to do this in sequence, that you can morph from one mesh to another mesh, saved coordinates of the mesh elements or the mesh coordinates. Is that about right? You're saving the mesh coordinates, or is that the wrong way to say it?
Your first, there's two parts to it. There's first something that just takes the grid itself and saves the weights.
Mm-hmm.
And if you're using the same grid spacing and everything, you only really need to do that once, so you can share it among multiple possible meshes. And then you would have the current state of all of these points. So how much weight of each of these points has been accumulated.
Mm-hmm.
And
so, I'll wait. Sorry, go ahead.
Oh, and then that's really all you need to do. You just need to blend between those weights, and you'll have these.
But Ed, translate that for us and tell us why that's great.
Well, I'll tell you what I'm hearing. I don't know if it's translate. So what I'm hearing is you have an initial set of weights for individual points there.
Right.
And then you have a final set of weights. And you can transition to the over time. But we're not using transitions in the easing sense here. We're just using a linear transition, basically, from one set of weights to the next set of weights, which gives us the final mesh.
Well, I mean, I was thinking of that I could incorporate it into easing.
That's where I was leading. So, like your example of the T1000, it wasn't just they said, here's our one image and here's the final image. We're just going to get there linearly. What they probably did was said, we're going to get there. Most of these will be linear, but some of these need to be eased to give it that better morph so you can really see the face coming out, right?
Yeah.
So you're saying the same thing is step one, linear transition for every weight. Secondary modification to this would be an interesting ability to change the easing of individual weights so you can get a different morph transition. Wow, I think that's what I get.
So Ed, if I hear correctly, what I'm hearing is basically like if we wanted to take two images today and we wanted to go from A to B and do a transition, I mean that would be pretty straightforward, and we already can do that. But what you're saying is that in each of these individual points, there is a point-to-point transition that's going on for each one of those individual points on that object.
Which at the moment that it is evaluated affects that mesh.
Right.
So with Stephen's addition or his what's the word I'm seeking here? His suggested addition, you could really change the way the morph looks over time by changing the weight and the easing of individual weights. So it wouldn't just be like, converting from a kitten face to my mug. But
it would truly be morphing a kitten face into your face.
That's right. You control the individual parts.
Okay. And so, Steve, is this? You said you're working on this as a plugin. Is this? How close are we to getting access to this? I mean, you still working on it? What's the?
Well, there's actually another algorithm that I have to make the editor for it. What's holding it up, really? And it allows you to actually change the directions of the morph, which I don't know. Maybe I should just release this part soon and then gradually add that.
That's right. There's nothing preventing you from having more than one version of this.
Yeah, and there's even texture stuff I want to explore too, because I've got some more papers I'm looking at.
What you shouldn't do is you shouldn't say, I'm not going to release this until it's just the way I want it. Because you may be like, okay, I'm tired of working on this.
I think this is almost ready as it is for this algorithm, and I could just add those others because I can just upload them later, really.
Yeah. Well, I think this is great. Vlad, mesh support, the updates that you've been working on, when do those go in, or when do they go in?
Already.
Say that again.
They're already in. Like, here's a link to documentation, and the Spine runtime already has, like, if you download from the Spine's like GitHub the runtime, it would have a mesh support.
Okay, so people can already use this today. They can already get access to it. Sorta?
Kinda, yeah. Like, there are some bugs in the mesh runtime, in Spine's runtime. They're open issue, and I put like a patch which just really dirty, like fixes up what's wrong with it. Like, it's just like stupid things. Like, my fix is really stupid. Like, basically ignore everything which tries to crash. So maybe animation won't be best. So I don't know. Like, I think it's gonna like come there, like eventually, and by eventually I mean sooner than later.
Okay. So, but this stuff is already kind of making its way into the daily builds and making it.
Yeah, it's already in a daily build. Like, there's like daily docs for it. Here's like link for it.
Okay.
Like, if you go to Spine's website, it's gonna have example how to, like, the Spine boy with a with meshes and it works. So like my Atlas loader, it's not in the Spine runtime yet because I don't know, I'm still working on it, and I don't think it would be accepted in that way I made it.
Okay. So it's still in motion. It's still a work in progress.
I got a question for you here. I noticed your mesh draw modes. You've got multiple, but you got strip and fan. Is the reason because we don't know which one's going to be more optimal yet, or is that just to give people choices?
I don't know. Basically, I would say go with the strip whenever you can.
I was gonna say, isn't strip probably the most performant?
Yes. I mean, strip is usually more like it provides like maximum flexibility. Really, I mean, with like fan is quite restrictive. Strip, it pretty much you can do anything. The problem with like there are a couple problems and it's mostly like optimization techniques. So the problem how indexed is implemented, it's not batched at all, unfortunately. But, it's like assuming you wouldn't have like too many like index mesh nodes, it's okay. Like if you don't have like hundreds of them, that shouldn't matter.
See, I always think that when Vlad says something is a problem, there's different definitions of problem. There's the my house was swept away in a flood. My entire family was killed in a car crash. And then when it comes to Vlad is like, well, it's not optimized exactly the way that it should be. And I'm like,
yeah,
that's a problem, but it's not your house getting swept away in a flood.
But as long as you don't have like hundreds of mesh nodes on the screen, indexed mesh nodes, it should be fine. You can have a lot like striped nodes, and if you're using the same atlases as your other assets, it should be even like seamless. Like, I don't think you would even notice creating new like display mesh objects if they're like striped. It's kind of tricky how batching works. Basically, it's very hard to batch different types of primitives together. Like if you have, striped triangles and right after you have, fan triangles, you can't really batch them. It's not how draw calls work. So Corona tries, for that reason, Corona internally renders everything in stripes. So if you can use the same texture atlases or image sheets, calls them, whatever, and you would use stripe in your meshes, it would really produce seamless batch, so it would be all rendered in one draw call. Hopefully. Yeah, with indexes it wouldn't work, unfortunately. It's like for now. For now, my goal was to get like best result I can in some given, so people have it and see if it's popular. If it would be very popular, I would totally go and like re-optimize everything. Yeah,
I always say cookies beat no cookies any day. Cake beats no cake any day, right? So having it is better.
It's a pretty good cake anyway. It's really, it's in a good state. It does like all optimizations if it can. So just one nuance, it doesn't like batches it very well when you use indexes.
Yeah. On the conference, I was asked about batching in Corona because apparently a lot of developers struggle with batching in other graphics engines, and they were curious how it's done in Corona, and I had nothing to say because I never had an issue with drawing a lot of stuff and skin and suddenly something would not appear for some reason. It just works in Corona, and they were just surprised that I don't know about this.
So Corona basically batches everything. Like it would do as much batching as it can. It actually does it. It would do batching if it can, but like if you worry about batching, you should know when it's possible. Like you cannot batch if you have different textures. You cannot batch if you have different shaders, because batching is basically just grouping up together a bunch of like different display objects and sending them to GPU at once, right? So if you have different shaders, you cannot just send them all together. Like, so if you have a big texture image sheet and lots of display objects using it, and they like render just one after another, it's gonna be batched. So it's gonna all be one draw call.
Okay, well, I tell you what, we're going to run out of time, so I think that's a good place to leave it. Let's come back to that at another date if we all think we need to get into that. And also, since we ran out of time, we will look at everyone's tips for new users and getting started. So if you have that already kind of figured out, jot down your thoughts, put it aside, and let's come back and talk about that next time. And then don't forget, tomorrow I'm going to be interviewing Chris Reed. He is an intellectual property lawyer in the gaming industry. So if you have any questions at all that you want to ask him, you can either leave those in the Corona Indie Facebook group, Indie Game Facebook group, or you can email them to me, charles@coronalabs.com, and I'll ask them of you, for you, by you, in your behalf. I'll ask them. So, all right, guys. Well, thanks for being here. We'll put all the links in the show notes. Thanks, Renee, again for sharing Quadtrees with us. Stephen, thank you for creating a plugin and sharing your knowledge with us. And Vlad, thanks you for just being so cool looking. I love that haircut, man. You're rocking that. Makes me want to go and get shaved on the side. Yeah. All right, guys. Have a great week. Happy coding.
Bye.
Interesting.